Right. So, where I am. So let me begin with the first tutorial session. So welcome everyone to platform-based development course, and this is going to be your first tutorial session in this class. So yeah, this is also the first time you met physically. So yeah, let's break into this course. So my name is Django. You can call me Daya, and I'm also accompanied by these assistants. Yeah, this is hello everyone. My name is my name is Randy. And at the back there is Muhammad Atala. He's currently quick fixing an issue in the website that provides you with the tutorial descriptions. So the game and also myself will deliver the tutorial session that is structured as follows. So the first 30 to 60 minutes, there will be some materials that we will refer to you all, like giving you an overview what you are going to work on in the tutorial, and then the remaining time that will be used for you all to practice with the given tutorial material. So if there are any exercises and also questions about the tutorial or even questions about the course materials itself, please feel free to question them during the tutorial session. And what else? Okay, that's all. Oh, one more thing. If you didn't bring your own computing device, you can also use the computer provided in the lab. The username to log into the computer is CSUI, and then the password is in all lowercase. In bahasa Indonesia, jangan makan minum di lab. That's the password to log into the lab. Or in English, JANGANMAKANMIMBILAB. That's the password to log into the computer in the lab. But yeah, I believe it's more convenient if you use your own computing device. So if you happen to bring one, just use it. But if you didn't bring your own laptop, well, you can use the provided PC in the lab. I think, yeah, that's enough for the introductions. And now let's begin with the actual tutorial. Oh, one more thing. This tutorial will be also recorded and streamed for those participants who have difficulties in attending the tutorial session. I remember there's one student that been confirmed COVID positive. So yeah, this tutorial session will be also recorded so that they can also participate remotely from their place. Because yeah, I think they are asked to isolate because confirmed positive in COVID. I think that's all. So let's begin with the tutorial. But before that, I want to know some of you. Let's see. Azuri Nauli. Oh, so you're Azuri. How should I call you? Azuri. Okay. Then Amar Asrik. Yep. How should I call you? Amar. Azra Batrisya. Azra. Azra. Okay. Diwa. Yeah. It's not able to come here. Muhammad Fiko. Fiko. Not present. Moza Adirafi. What should I call you? Moza. Okay. Raizas. What should I call you? AI. Okay. AI. Okay. Shafiko. Should I call you? Fico. Okay, so there are 2 Fico in this class. Okay. So, and then Muhammad Akbar. Nafis Azizi. Nafis. David Cristianto. David. Alomuan Geraldo. Aldo. Julian Justin. Julian. Okay. Kalush Palito, ya. Kalush. Matthew Rizky. Matthew, not here. Okay. Nicholas Ananda.
Present, sir. Hello, sir. Hello, hello.
I see. I remember something. Okay, thank you. Nicholas.
Yes, sir. I'm present, but
Rafael,
meeting.
should I call you? Rafael. Okay. Yeah, Nicole, Pangabian. Nicole. Tessa Lodarsax. Okay, not here, and also not in Zoom either. Oh, right, I saw some chat. Right. Okay, get well soon, Nicholas. Linnea Alijah Khan. Here. Lim Ming Yuan. Eric Lim, right? Yeah. Huh? Oh, Dylan. Oh, you're Dylan. Oh, not here. Yeah. I'm sorry. I thought you are Lim. I'm sorry. Yeah, he's not here either. So yeah, I hope the recording will be helpful to you all. For those who not able to come here today. And is there anyone who hasn't been mentioned? Dylan. And then what's your name? Muhammad. Fico. Oh, you are Fico. And then right. I think I should just write some notes here. So let me go through from you, Dylan. What's your full name again?
My name is Dylan Dahlan.
Dylan Dahlan pribadi. Dahlan.
Using R for. Yep. Exactly. Thank you.
Okay. And then Muafiqo already. Muhammad Aldi. Can you spell your name? H. DH. DH what? Oh, oh, right. I can just look at the scale. Okay. I'm sorry. It's easier to just look at scale, right? Yeah. What is it again? Users. Yeah, because we have to wear masks, so it's a bit harder to pronounce some words. So yeah. I can show you what's again. Muhammad Gazian. Okay. Gazian. And then who else? Who hasn't been mentioned? Yep. What's your name again? Jovian. Right. Jovian. Yeah, I'm asking this because the student list here is not yet finalized. So yeah, it's just for noting the attendance. Okay, without further ado, let's begin with the actual tutorial. Okay. So the first tutorial will be about Git. Have you ever used Git before? Some do, some haven't. Yeah. But let me ask you another question. Have you ever used Google Docs before? Almost everyone have used Google Docs before. And when you are using Google Docs, or also other applications like Word and also even Notepad, if you made some mistakes, what can you do about that? Undo, right? So you can use Ctrl-Z to revert your changes to the previous version. Git is the tools that we are going to use in this semester functions similarly to that, but it's more a bit complex compared to Google Docs because we have to be explicit when we are saving our changes to the files that we are modifying. And Git also provides several functionalities that will help you work on source code files or actually almost anything as long as the files are written in text format. So Git will help you in managing those files and ensuring that any changes to those files can be ensure its integrity. And you can also know the record of changes happened to the file. So you will know that whenever somebody made changes to the file, you will know who made the changes and when they made the changes. That's one featured example that provided in Git. And also, in this tutorial, since we also ask you to bring your own computing device, let's use this moment to prepare your development environment. So if you haven't installed Git, Python, or text editor, you can do that during this tutorial session. So what we recommend is please install Git from the website. If you are using Windows, you can install Git provided in the link website. If you are using Mac OS or Linux, such as Ubuntu, Arch Linux, and other distros, you can use your operating system package manager to install Git. And then ensure you are using Python, the latest version if possible. And also install a text editor or IDE. In this course, we recommend you to use Visual Studio Code with Python and editor config extension. But if you want to have a more complete text editor that has more features than Visual Studio Code, you can also install Python Primitive Edition. It's more function like an IDE than text editor, so it has several shortcuts that will help you in developing Python-based project. And if you want to be more adventurous, you can also using Vim. in your PC. And yeah, also in this semester, we are going to use an online Git repository hosting called GitHub. So if you haven't created a GitHub account, please create one now, because the instructions in the tutorial will ask you to create a Git repository locally and then push it to GitHub. Okay, so let me give you one example on how to do that in my own PC. So let me open something called the terminal. I think sounds better. So let's say you are using Windows and also you already installed Git in your PC. You can verify whether the Git has been installed or not. If Git already been installed, you can type git -- version to see the version of Git that installed in your PC. If you already convert and Git already been installed, then you can follow through the tutorial. So for example, the first instruction in the document is about creating a new repository, right? So in order to create a new repository, let's say we go to a folder. I like to organize my folder in this way. Let's say I want to create a new repository. Let's say call it the repository awesome favorite games. This is just an example, okay? The one that you have to do in your tutorial is the instructions described in the document. This is only for demonstration. So this is a new folder called Awesome Favorite Games. And then in that directory or in the newly created directory, call git init dot. So the commands are git referring to the executable, and then init is the option in the Git program, and then the dot is referring to the path where the repository will be initialized. And usually both in Windows and Linux and Mac OS, dot is referring to the current active directory. So if you are currently in this directory, let's say workspace, CSUI, PBP, awesome favorite games, then dot is referring to that directory. And then you can confirm that you already created the Git repository. If you are using Windows, well, try to go into this directory, cd.git. If it works, then it means your Git repository has been initialized in the directory. If you cannot change directory into .git directory, then something wrong must have happened during the initialization process. Up to this point, are you following? Or is there any question before I continue? Okay, cool. And you can also verify if you already created the new repository by typing git status, and it will produce some messages like detailing what is the name of the currently active branch. So by default, every repository initialization will provide you what called as branch. Let's view it like a tree. Are you currently taking data structure or have taken data structure course? Currently taking?
Yeah.
Okay. So later on in the data structure course, you will learn about tree data structure. But in this case, let's imagine you see a tree. And usually a tree will have a trunk, right? A big trunk. And then the tree will also have several branches coming out of the trunk. Now, the main branch here can be viewed as the trunk of a tree that will represent the source code that you are developing using Git. Well, not developing using Git, but stored in Git. And during the evolution of your source code, whenever you make changes, adding files, removing files, modifying files, those files can be persisted. The changes of the files can be persisted in the trunk or diverged from the trunk in the form of branches. So you can maintain separate version of the files in different branch from your trunk. Okay, now let's try adding a file to be tracked by Git. So we are going to add file whose content will be tracked by Git. Let's say I'm going to create a file called readme.md. This is usually the common pattern when developing a software project. So you prepare a document that describes your project, like what are the features and also some short instruction on how to compile and build the project. So let's say I'm going to name this readme awesome favorite games. This is an example of readme.md that is used during tutorials. And let's say I'm going to list some of my favorite games in this readme.md. My favorite games. So what are the currently popular games that you are all playing? Can you mention some of the name of the games? FIFA, okay. FIFA 2022, okay. What else? Minecraft. Anything else? Solitaire. I also saw some people in Discord playing this game called what? Tower of Fantasy. Some people currently like to play this game. And also, what else? Genshin Impact, right? Well, my favorite is actually S Combat. So this is my personal favorite. Now, let's save this file and see in the directory. There's already a file called readme.md. And now, if you type git status, you will see that Git reported that there is an untracked file called readme.md. It means that Git noticed that there is a file that hasn't been tracked by Git. So what we are going to do is to add that file into Git repository in our PC. Using Git add. Yeah, we can ignore that for now. Now if you type Git status again, the message changed from untracked files to changes to be committed. So now we already tell Git that we have this new file called readme.md, and then we want to formally store this file into the Git repository. So it's unlike Google Docs or Dropbox or OneDrive where we can just simply add our files into a folder. When we are using Git, we have to be explicit So whenever we make changes to the files, we have to tell Git what file that we have changed. So Git then can store the file into Git's database. So we already have this file. And if you are following through by reading the tutorial instruction, yeah, it should be similar to the one that I'm currently demonstrating. So we already told Git we are going to add this file. Then the next step is to commit it. Commit is like creating a certificate to certify your changes to be inserted formally into the Git's database. So this is what I mean by we have to be explicit whenever we make changes to the file stored in Git. So we git commit, and then an editor usually will pop up in your screen. In latest Git installation in Windows, they usually use Notepad or Visual Studio Code to let you write a commit message. But in my case, it's a bit different, where I type the commit message directly in the terminal. Okay. So when you make a commit, you have to describe what kind of changes you are going to make in the file. So in this case, since I just created a new file called readme, yeah, let's just describe the commit message as such. Create a readme.md file. Then save it. Right. Hold on, I have to do some debugging, updating the configuration of my own configuration. Create a readme.md file. Okay, now it's there. So once you have created a commit and then you type git status, you will see that Git reported that no change to commit. The tree is clean. So Git already stored the readme file into Git's database. And if you want to see the record, whatever changes happen into the repository, you can just git log. Now, in the git log, you can see that currently there is one commit here that described with message create a readme.md file. And the commit was created at this timestamp by myself. So that's one example of making a simple change using Git. Any questions so far? Not yet? Okay, so let me demonstrate to you what should be done if we are making changes to a same file concurrently. So if you are using Google Docs or Microsoft Office Word, you can actually edit your document concurrently, right, together with your friends. In Git, it's also possible. However, you cannot do it in real time because remember that every changes in Git must be made explicitly. Therefore, if you are concurrently editing a file, there is a possibility what is called as merge conflict. So let's say I'm making a change to readme.md file, and at the same time, another people that has my copy of repository in their computer also making the same change, a bit with different content. And let's say if both of us try to integrate that changes back into, let's say, when we put the changes back into GitHub, then it's possible that the Git repository will confuse because the same file was edited by two people at the same time and it contains different contents. So there must be a way to resolve that discrepancy between my changes and the other people's changes. But before that, let me simulate that case locally. So let's say I'm going to work on the source code in my own copy, and then the next person that I'm collaborating with will also using the same PC as mine to make the changes to a file. So let's say I'm going to modify a file. So usually the best practice when doing software development is when you are developing a new feature or creating a set of changes to the source code, it is recommended to create a branch first. Remember that currently in the main branch, you can view this as the trunk of your source code. And whenever you are going to make changes, you will start from creating a branch that later will be integrated back into the trunk, aka the main branch. So let's create a new branch. Let's say my own branch. Let's call it Daya or your own name. Then in this branch, I'm going to make a change in the written file. Let's say I'm going to be more specific. I'm adding a new game. Let's say a game. Zuma. Okay, so I added Zuma in between solitaire and tower fantasy here. And maybe also I'm going to be more specific. For example, instead of S-Combat, then S-Combat, I'm going to be more specific to refer S-Combat 7 in this case. Git status, and I'm going to update this change. Update readme.md. Now, I'm going to let one TA, Winaldo. So, Winaldo is going to create a new branch. Yeah. Yeah. You. Oh. Then yeah. Let's say you added a game between solitaire and tower fantasy. Okay, that's good.
Is it enough?
And let's try you edit S-Combat to S-Combat 0. Yeah, that's enough. Yeah, that's enough. 0. And let's save it. And yeah, and commit it. Yeah, this is also one shortcut to write commit message. So you use -m option, then followed by your commit message. Oh, cool. Thank you, Rinaldo. So right now, we have two versions of the same repository. Not the repository, the source code. So we can use git branch this AV, for example. And you can see the list of branches currently exist in the local repository. Right now, it has 2 branches in our area. Both contain a new commit with different IDs. So commit is uniquely identified by a string of letters and numbers. For now, you don't have to care about that, but just know that every commits are unique. And in this example, I'm going to merge my change back into the trunk or the main branch. So there's a command called git merge that you can use to merge back a branch into the currently active branch. So right now, the currently active branch can be queried by using git branch, and you will see the currently active branch is labeled with asterisk sign inside the name of the branch. So right now we know that the currently active branch is the main branch. And we can merge a branch into the main branch. Let's say I'm going to merge my own change first. And then, yeah. So the commit from my own branch has been not copied, but rather well, what should I say? So previously, okay. So the commit from my branch that has this unique ID 87B78F2 has been linked as the successor of the previous commit in main branch. So if you look at the log, I think I can. So previously, the first commit in the main branch is the commit with ID 1C99331. Then, after I merged my own branch into the main branch, the commit from main branch, whose ID is 87B78F2, is linked as the successor of the commit with ID 1C99331. So if we visualize it like a chain, let's open Notepad. Format font 72. So previously, the first commit is the commit with ID 1C99331. After I merged the commit from my own branch, now 1C99331 has a successor commit with ID 87B78F2. So by having this kind of structure, we can know how the source code is changed throughout the lifetime of our project. So initially, the source code is defined in this commit 1C931, and then somebody merged a commit from a branch, and that commit is set as the successor or the next commit after 1C931 with this ID. And then let's try merging Winaldo's branch. This is the fun stuff. Usually Git is trying to be smart. Git tries to auto merge the differences found in a file that modified concurrently from say, multiple branches. However, in this case, Git cannot resolve the difference. So Git will ask you to fix the difference by triggering a merge conflict. Now, what happened in a merge conflict is the file that has problem being resolved by Git has this kind of annotation. So the head here is referring to the version of file in the active branch. So in the active branch, this section of file contains Zuma, Tower of Fantasy, Genshin Impact, and Combat 7. But then from Ronaldo's branch, the same section contains Valorant, Tower of Fantasy, Genshin Impact, and Combat 0. So the question is, which version we should use? We should use as the authoritative version in the main branch. Is it my version or Ronaldo's version? That will happen when you are working with your own project individually and later with your group. You need to decide which version is the correct one. Are you going to use your own version or your friend's version? Or it's also possible to just remove this conflicting section or input both changes from both branches into the solution, into the final version. So in this example, I'm going to merge both versions. So let's say, since I mentioned Zuma and Ronaldo mentioned Valorant, let's merge those into the list. So I move Valorant to one line below Zuma. And as for the Combat 7, there's a conflict right here. My favorite version of Combat is Combat 7 and Ronaldo's favorite is Combat 0. So which one is going to be the final version? Is it 7 or 0? Yeah, I can discuss with Ronaldo, but I don't know whether he likes Combat. Do you like Combat, Ronaldo, or have played Combat before? Not yet. Okay. Maybe we try to be more diplomatic since Ronaldo hasn't played Combat before. Maybe we can just remove Combat from the final version. Then, for the overlapping changes like Fantasy and Genshin Impact, we can trim them down. Just since both mentioned multiple times in my branch and Ronaldo's branch, let's filter it. Just mention the both games once. And then the annotation that indicates the source of the conflicting changes need to be updated, need to be removed. And then save it and check the status. In the status, it reported that there is a merge conflict. And if you have resolved the merge conflict, like what I just demonstrated before, you need to add the final result of the merge conflict resolution to Git by using git add. And then commit it. If you're making a commit from resolving a merge conflict, Git usually provide you with a default commit message template like merge branch Ronaldo. But if you follow the example that Ronaldo just before, by specifically writing a commit message, it's also possible. That's also possible to write your own commit message when doing a merge commit. So let's just use the template one. And yeah, now the README file only contain the final result of the merge config resolution. Now it has FIFA, Minecraft, Solitaire, Zuma, Valorant, Open Fantasy, and Genshin Impact. Okay. Up until this part, any questions? Not yet. Still easy enough to follow. All right. We haven't reached that part yet. Okay. Now this is the current history of the Git repository. And right now the Git repository is stored locally in our PC. And since we want to let the other people in the world know about our awesome list of games, we can put this repository online on GitHub. So let's say on GitHub you created a new repository. Let's create a new one. Example. Git demo example. I'm going to make this public for now. I'm sure the repository is empty. If you want to make your local repository to be synchronized to the online repository that you created on GitHub, the initial steps are already explained on GitHub. So if you're creating a new one from scratch, you can follow the first section of the guide. Or if you already have an existing repository, then you can follow the second section of the guide here. So I'm going to follow this one. I'm going to get to my shell. Yep. And it's already been pushed to GitHub. And if I refresh the page, now it's already there on GitHub, and the other people can copy it to their own PC, or suggesting changes, or even contribute back into the repository. So that's one part about Git and GitHub. So you can use Git to track changes to your files, and then the history of changes of your files can be uploaded to online Git repository such as GitHub. Okay, that ends the first part about Git. Any questions before we move on to the next part about Heroku? Yep. Oh, okay. Can you be more specific? Right. Okay. Okay, let's say I'm going to create another example. So if you created a local repository first in your own PC, the repository doesn't know the other location where the repository can be shared. So right now, the Git repository only live locally in your own PC. And if you want to make your local repository to be shared to another repository on GitHub, for example, you need to modify the list of remote. Right now, the remote is empty. Okay, before I proceed further, remote is the list of Git repositories. So you can add several one or more Git repositories into the remote. And if you already put some Git repositories in your remote, you can push your commit to that particular Git repository. So, for example, let's say I'm going to create another example. Where is it again? New repository. Let's name it another example. And the repository is empty. Now, at this point, we actually have two repositories. If I have to visualize it, my PC has another example, the Git local, and another example, the Git on GitHub. So right now I have two repositories actually. The first one is in my own PC, and then the second one is on GitHub. Both are still empty. If we want to make a linkage to connect the local repository with the one on GitHub, we have to add the location of the another repository into our remote in local repository. So we add git remote add, and then we give it a name. Usually, the name of the online repository that will contain our copy of local repository is named as origin. So that's the default convention in naming a remote. After that, you put the address, the location to the remote repository. In this case, the location of the repository on GitHub. And if the command is successfully invoked, you can see in git remote -v. You see that there is a new remote called origin, and that origin is associated with this address that points to a Git repository of GitHub. Let's say I'm going to create a file. Okay, this is for shell. Hello world. That is with me and commit it. Initial commit. Git config. Commit. And I try to push it. Right now, if we want to push a commit from our local repository to the remote on GitHub, to the remote repository on GitHub, we have to associate the branch in our local repository to the designated remote. Because currently the main branch in our local repository doesn't have the counterpart on the remote repository. So in the initial commit, let's say when you are going to push your local repository for the first time to GitHub, you need to associate main branch to the remote that you want, where the remote repository is located. And by doing that, your local branch, your main branch in local repository will be uploaded to Git repository on GitHub, and the same branch called main will be also created. And if it's done successfully, it should, yeah, it's there. Does that answer your question? Okay, no worries. Right. Anything else about Git before we move on to the Heroku part? Okay, if there are no questions, I think we can go briefly with Heroku since we already kind of limited with time. Okay, first of all, have you ever heard Heroku before? This is your first time heard about Heroku? First time, okay. Yeah, how I'm going to explain this. So when you are later on, when you have created your Django web application, your application needs to be deployed. I mean, the one that going to use application is not your own self, right? You want to make your application to be used by other people. So you want to make that application available to everyone in the world. And in order to do that, you want to put your application to a server that will be accessed by other people in order to access your application. And there are several approaches in doing this. You can set up your own server. So you buy a server, put it in your bedroom, for example, and connect it to your internet and associate your server's IP address with a domain name so that other people who try to access your application hosted in your own server in your bedroom can open your application. You can do that. But again, yeah, there are several considerations like cost, maintainability, like server is very expensive usually if you buy the real hardware. Another approach is we are going to use, or more accurately, rent an existing infrastructure provided by other people. So we rent a server provided by other people so we can run our application there. And in this case, Heroku actually function similar to that. Heroku rents their collection of servers. They have a lot of servers. And they rent it for free for now to other people so they can put their web application in Heroku server so it can be accessed by other people from the internet. So let me show you what Heroku is. Let me log in. yeah, I need to use authenticator. Heroku, where is it? 377778. Yeah, it contains several applications for now. For example, it's already been mentioned here. So at the end of November, Heroku will stop providing you with free dynos or servers. So yeah, later on you will need to use another platform for deploying your application. But yeah, for example, in my Heroku here, there are several applications that already deployed on my Heroku. Let's say this one is a Java application that I developed for a training. It's Java based and can be accessed in, yeah, after I click this open app. So Heroku, when you are using Heroku, Heroku will require you to submit your source code to Heroku. And the submission process is actually by using Heroku CLI that provided by Heroku. Or it is also possible to use Git to push your repository to Heroku. And then if your source code in your Git repository matches the convention and rules required by Heroku, then your source code can be compiled and then run as web application by Heroku. Oh, yeah, this is the application that I already deployed on Heroku. So that's one example. So I have a Java source code, and then the source code is pushed to Heroku, where Heroku will compile it. And once it's been compiled, Heroku noticed that I used a web application development framework, and they invoke the command required to run that application that was developed using the web application framework that Heroku noticed. And how Heroku serve your application, for example, the application itself is running on different port actually from the common port used for web data transmission. Heroku automatically handle that part, so you don't have to worry about that usually. So if you have source code that match Heroku's convention, you can push it to Heroku, and then Heroku will compile and build it, and then run it as well. Yeah, in the tutorial document, once you already set up your own Django app in a Git repository, you can follow that document to set up an automatic deployment pipeline. So whenever you make changes to your application and you push it from your local repository in your own PC to GitHub, the latest changes in GitHub will be automatically deployed to Heroku. So the guide is already available in the document. So if we see the document, you can see that it mentions several things that you have to follow before you are able to deploy your application to Heroku. For example, Heroku usually expects a file or prop file that contains a command that will be run by Heroku in order to run your application. So in this example, we are being explicit. We tell Heroku to run this command to run the Django project that we deploy on Heroku. And then the next code snippet here is the process that will be executed by GitHub in order to deploy your latest changes on GitHub to Heroku. So we'll use server running Ubuntu Linux that will plug your repository into that machine provided by GitHub. And that machine will be installed by several things like Ruby, programming language, EPL, package, Heroku CLI program, and then that there is a command to deploy your application to Heroku and perform what is called as data migration. You will talk about this later. Then label that deployed application as a deployed environment on GitHub. Maybe the one that you need to be careful is about Heroku API key and Heroku name. API key can be obtained from your Heroku's profile. So in account settings, you can check your API key here. Well, yeah, you can see that. So this API key needs to be put into the GitHub secrets. Where is my GitHub page again? Right. Let me open my GitHub here. Yeah, let's say I have this project. I have some experimentation with Django in my own GitHub. Let's say I want to deploy this project to my own Heroku. So I copy the API key and then go to my repository settings on GitHub and go to secrets menu here in the left side. And then choose action. Well, I already put there, but yeah, this is the step by step. So once you already copy your Heroku API key from Heroku, you create a new repository secret, put the value there, and give it a name. If you are following the tutorial, you put it like this: Heroku API key, and that Heroku API key will contain this value, which in turn will be let's go back to the document. This will be read by the process for deploying the application to Heroku. So the API key here will be read and then stored into a local variable in GitHub server called Heroku_API_key. And similarly, the app name on Heroku is read from the secrets that you put in your repository setting into the variable that's available in the server on GitHub. And those values will be read by this command dpl, where the dpl command require the app name and also the API key required to deploy your application to Heroku. And yeah, let me go back to what else. And you can see the process in the action step. So let's see in the deploy here, you can see how the process was executed by GitHub to deploy your application to Heroku. And later on, during this course, you will also learn more about GitHub Actions. So you can, for example, test your application whenever you push it to GitHub. So once you already have created some tests regarding your application, you can execute them each time your application is pushed to GitHub to ensure that your application still works correctly after you made some changes to your application. But yeah, that's for another time because yeah, today we only focus on introducing Git and also Heroku. Okay, any questions regarding GitHub and also Heroku? Okay. Yeah, that's basically the tutorial session. Please complete the instructions described in the tutorial description. If you have any questions, you can ask me or the TS available there. So yeah, I'm going to that ends any about introducing Git and Heroku to you all. Now we let you all to do the task described in the tutorial description. So if you have any question, just ask it immediately. I'm available and so do the PAs. And for those who are participating from Zoom, oh right, interesting. If you bring your own PC, actually you can also join to the Zoom room because I believe it's more easier to see the share screen via Zoom instead of looking at the projector, right? So yeah, it's you can also do that. So you open Zoom and then look at the shared screen from the PC, from my PC, or maybe later on from the TS PC. Yep. Pardon, I didn't really catch. Oh, right. You go to the settings of your repository on GitHub, and then in the left side of your setting page, there is a menu called Secrets. You click it and then pick Actions. After you've done that, you create a new repository secret. Then you define the name of the secret and then the associated value for that secret. Yep, no worries. Yeah, basically you are asked to complete the tutorial. If you already finished, you can go home actually. But if you are not finished yet, and if you have some problems, you can just let me at the PA's notes, so we can try to address those problems immediately during this tutorial session. Yeah, the chat is still empty. What else? Yeah. What else? Show the tutorial description. Just a minute here for now. What is it? September. Okay. Students get listed in the perspective. Okay. Save. Oh, right. Six. 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 Eight. Seven. Is it? The previous class session was 15 August. But yeah. One, eight. It is it. August. Five. Two. Proceed to this. Okay. Okay. Yeah, it's already 11:50, so we have reached the end of tutorial session. If you have any further questions, you can ask the teaching team, myself, and also the PS through Discord or through Scale by writing a new post in the forum. If you want to stay in the lab, feel free to do so, but at 1 p.m. the lab will be used by another class. So yeah, you are allowed to in the lab until 1 p.m. So thank you everyone, and yeah, I'll see you later in the next class session online. And yeah, for those who are participating from Zoom, yeah, see you.